All right, so I wrote a book. It's about epigenetics. 7 years of work, 400 pages, 750 citations. I think you should not write a book. It's a lot of work. Why write a book? I liked some of the things that I was reading as I was researching the history of this field. For example, Waddington and others who were writing books in the earlier part of the 20th century, it was a way of communicating. And what they were doing was they were surveying the field of research, but they were also interjecting some of their own opinion into it in a polite and respectful way. And so I found that a very interesting model, and it's what I hoped to emulate in the book. It's also a way of having a series of linked reviews. If you've got a chapter on molecular techniques, another on cancer, another on human disease, you can start referring back and forth between them in a way that your average review these days wouldn't really allow you to do. But the key to unlocking how I should write this book in the first place was to anchor everything in history, and that was a lot of fun. Went all the way back to pre-antiquity, northern, what is now India, the Benares province, and this fellow Sushrath and his original ideas about how fertilization took place, all the way through to Aristotle, who did not invent the word epigenetics. That was William Harvey, who was the king's private physician around the time of William Shakespeare in England, all the way through to the battle between the pre-formationists and the epigenesis advocates. And it was the time where microscopy had been introduced, so we should have seen evidence for one versus the other, pre-formationism versus epigenesis. But of course, when you have a very good story like pre-formationism, and people are already locked into being on one side or the other of, whether the homunculus is in the sperm or in the egg, it's very difficult to get people to believe the evidence of their own eyes. And that's where this Wolf was the key person to make change in that field based on his careful microscopy. But for his heresy in not believing what all of the professors in Germany believed at the time, he couldn't work in Germany. He was recruited by Euler, he of diagram fame, and by Catherine the Great to work in St. Petersburg. So schism has always been part of what we do in science, and it really crops up over and over again in the history of epigenetics, especially when you go forward to the 20th century. Now pre-formationism has been debunked, and now you have epigenesis as this incredible field, lovely observations being made. But then the geneticists come along, and they're showing that some mutations of the genome are heritable and are causing phenotypic effects like the white eyes in Drosophila, kinked tail in mice. So they're saying, there has to be a genetic influence and in development. And of course, this was where Waddington stepped in and said, yes, you can have both. You can have cell differentiation and epigenesis and genetics, and that's his idea of the epigenetic landscape. So having this word epigenetic come up was kind of interesting, because it turns out that it's a term that was already in the use in the world of geology, and Waddington was actually originally a geology student. So I speculate in the book whether he was actually trolling the field of biology by reusing this word from geology in a different context. But it also was a term that underwent reinvention over time. David Nanny, a tetrahymena researcher, used the word to describe the mating type preference in tetrahymena, only after he was persuaded to do so by Guido Pontecorvo, and Nanny's defenses were down because he was very travel fatigued. Long story. John Pugh, who was inspired by the wonderful scientist Ruth Sager. John Pugh and his 44 miles on a bike come up in the book, and how he came up with the word epigenetic, not knowing anything about Nanny and not knowing anything about Waddington. He was trying to get his abstract written in a way that would fit into a 200-word limit, and he had to coin the word epigenetic as a result. So we have some other great stories in there. Peter Jones, the epigenetics oncology researcher, has a graduate student training story that is second to none. There's some great stories about Susumu Ono and his discovery of X chromosome inactivation. And then I think what I try to do is to reframe how we should be thinking about epigenetics. I think it's obvious now in the era of single cell technologies, genomic technologies, that we should be thinking of the unit of organization for transcription regulation being the cell. But we should probably rethink some of the disease associations. There's no real evidence of human diseases that are caused by epigenetic mechanisms. All these so-called epigenetic diseases, Beckwith-Wiedemann, Russell-Silver, and so on, they're actually genetic events that reveal epigenetic mechanisms. There's no real evidence that you can have reprogramming of cells that cause human diseases. And that's an interesting and probably disturbing discussion in the book. The question of where to fit transcription factors into all of this is, I think, going to be disturbing to other people who are my colleagues in this field, because we are saying that when we find these events in the genome, they're actually footprints of transcription factor activity, and everything else that we have been calling epigenetic regulators are secondary. And if you think about what regulates transcription factors, we're bringing all of this back to cell signaling, which is probably a little bit too cell biology for a lot of people. And also we have the fact that the polymorphism that exists between my regulatory loci and yours are probably driven substantially by DNA sequence variants between us. So as epigeneticists, if we have to go back and relearn things like Hardy-Weinberg and other genetics principles, that's probably necessary, but it's also quite disturbing. So there's some questioning of assumptions that are going on, that is going on in the book. I also think that we should go back with modern techniques to some of the foundational experiments that have prompted millions of dollars of grant funding and tons of papers and whole areas of research, like transgenerational, intergenerational heritability. Those Vin-Closelin experiments could be done so much better today. The maternal licking and grooming model in rat, likewise, I think is worth further scrutiny, and I go through that in the book. And we have to recognize that a lot of these foundational studies were performed with just tens of animals, whereas a recent study that Jamie Hackett performed in Rome, looking at an intergenerational effect, had to use over 2,000 animals, which is problematic by itself, but it was enough to give him confidence in his results. So we have a book which is out there intended to provoke discussion. I am certainly not trying to diss any colleagues who have been doing such wonderful work over the years, but I am bringing up things where I think we could be doing better, because what we should be asking is that the next generation of scientists do this work in ways that are better than how we have done it to date. We have to have improvement. We could have more rigor. We could have better thought processes going into this work. And if the book is in any way influential towards that goal, I will feel like it has been a success.